Okay, so the last little topic in this section is on matrix equations, and it's not going to be anything too complex as far as complex equations, not like multi-step polynomials or anything like that. These are just very basic equations, but with matrices work a little bit different than the way you solve equations with like real numbers. Um, so let's talk about how we can use this to solve a system of equations. So if we have this system here, we have three equations, three variables. We can write the matrix of the coefficients on the left side. Um, so these are just the coefficients with the x and the y and the z. And then we can write the variables as a matrix like this, a 3x1 matrix. And then we can write the right-hand side as another 3x1 matrix. So if we let A be this matrix of the coefficients, we'll let X be the matrix of the variables, and we'll let B be the matrix of the solutions. We can write this system of equations as a matrix equation, AX equals B. Um, and notice if you write or if you multiply out this matrix by this one, you end up with x minus 2y minus 4z, and then 2x minus 3y and 6z, so and so on. And so you would essentially have these three equations. So we're just kind of rewriting those three equations in a matrix form. And so we have the matrix A as the coefficient matrix. And now what can we do with this? So we essentially want to solve this equation for the matrix X, and then that would give us a solution. But we can't we cannot divide matrices. So you can subtract matrices, you can add them, you can multiply them, but you cannot divide them. But what you do instead is you multiply by the inverse. So essentially, and you can think of this like if we have the just regular equation 2x equals 4. You obviously you can divide by 2 and that solves the equation, but you can also multiply by the multiplicative inverse of 2, which would be 1/2, and that would accomplish the same thing. And so you cannot divide matrices, but you can multiply by the inverse, assuming it has an inverse. So that's all we're going to do here. So you can solve this AX equals B equation for X by multiplying both sides by the inverse of A. So if we do that, and it's important that order matters when you're multiplying matrices. So make sure you don't put the A over here, the A inverse over here. We are what's called left multiplying by A inverse on the right or on the left. And so we need to left multiply by A inverse on the right as well. And so the A inverse and the A just gives the identity matrix. So those will cancel each other out. And then that leaves X equals A inverse times B. So let's look at an example. It's just a 2x2, so this won't take as long as that last one did. So let's write our matrices here. So we have 2, -5, 3, -6, and then our X is just X and Y, and then our B is 15 and 36. So it's just another way that we can solve a system of equations, provided we have the square matrix A. If A is not a square matrix, then this doesn't work because you cannot find the inverse. So we have 2, -5, 3, -6 times xy equals 15, 36. And so we need to find the inverse of A. So then xy would equal the inverse. We'll find that. And then times 15 and 36. So let's find the inverse of A. So A inverse would be 1 over, so we had that formula that we talked about in the previous video. So AD minus BC and then we switch the A and the D, and then we change the sign on the B and the C. All right, so that gives us 1 over, so that'd be negative 12 plus 15, so 1/3, negative 6, 5, negative 3, 2, and then we'll multiply each of those entries by the 1/3. So we get negative 2, 5/3, negative 1, 2/3. And so that would be our A inverse. So negative 2, 5/3, negative 1, 2/3. And now we just have to multiply A inverse times B, and then that gives us our answer. So we have negative 2 times 15 plus 5/3 times 36, and then negative 1 times 15 plus 2/3 times 36. So we have negative 30. This would be 5 times 12, so that'd be 60. So negative 30 plus 60 would be 30. And then we have 2/3 times, that'd be 24 minus 15, so that would be 9. And so that should work as long as you did everything right. But that's the idea. So all you need to do is find the inverse of A and then left multiply by B. And so you always end up with X equals A inverse times B. All right, so nothing too complex. This is just another way to solve these systems of equations. So if you have any questions on this section, feel free to let me know.